Hello, yeah. So I guess everybody is here. So we were discussing about straight lines. Okay, we have discussed about linear functions, then graphs of linear functions over straight lines. Now we are discussing about the straight lines, its properties, and things like that. Okay, so we are on problem sheet number 25 from the previous week, right? We have completed question number 1. Let's quickly finish the other questions as well. See, after this, we have to move on to system of linear equations. Okay, when you have two linear equations, how do you solve it? You can solve it graphically. You can solve it using elimination by substitution. Okay, there are multiple ways to do that. Okay, we have to move to that topic soon. So, but before that, let's finish these questions. What is the equation of the line through the point 0, 8 and 2, 0? What is the equation of the line through 0, 8 and 2, 0? So did you guys solve this question? Please let me know. Question number 2. Question number 2. Did you guys solve this question? Hello. Did you guys had a look at this question? Question number 2. The equation of the line through the point 0, 8 and 2, 0. See, in the previous class, I've told you how to find the equation of a straight line when 2 points on a line are given. Okay, when 2 points on a line are given, see, this is the equation of the line. It's y minus y1 is equal to m times x minus x1. M is nothing but delta y over delta x. The slope is nothing but delta y over delta x. Okay. So if you know 2 points, you can definitely find the equation of a straight line because the slope of the straight line is, let's see that question once again. But there is an easier way to do it. I'll also discuss that. First of all, let me do it in the normal way. In this question, there's a shortcut. So if I have the points as 0, 8 and 2, 0. 0, 8 and 2, 0. 0, 8 and 2, 0. See, first method is find the slope. So slope is y2 minus y1 over x2 minus x1. Of course, this is x1, y1, x2, y2. So change in y coordinate is going to be 0 minus 8. Change in x coordinate is 2 minus 0. So this is minus 8 over 2, which is minus 4. Minus 4. Now, you take y minus y1 over x minus x1 is equal to m. Take y minus y1 by x minus x1 is equal to m. So instead of y1, x1 and y1, you can take x2 or x2, y2. That is also possible. It will not change the answer, okay? So we have y minus y1. y1 is going to be 8. X minus 0 is going to be minus 4. All right. Is this clear? So far, so good. We have already discussed this idea in the previous class. If you have any confusion, please let me know. If you have any confusion in this, please let me know. Yeah, so the answer will be y is equal to minus 4x plus 8. Y is equal to minus 4x plus 8. Or you can say y plus 4x is equal to 8. Y plus 4x is equal to 8. y plus 4x is equal to 8. Okay, to match the option, what you have to do is you have to divide the entire expression with 8. And so this becomes y by 8 plus 4x by 8 is equal to 1. So x over 2 plus y over 8 is equal to 1. So this is the matching option. X over, x over 2 plus y over 8. This is the matching option. Okay, this is one way to solve it. This is one way to solve it. Okay. Another method is you can use y is equal to mx plus c approach. The equation will be y is equal to mx plus c. Now you have a pair of points given. And the pair of points are 0, 8 and 2, 0. 0, 8 and 2, 0. You can use this approach. So if I apply 0, 8, 8 is equal to m times 0 plus c. So c comes out to be 8. You substitute 2, 0. When you put 2, 0, 0 is equal to 2m plus c. C value is 8. So we have 0 is equal to 2m plus 8. Your m value comes out to be minus 4. Your m value comes out to be minus 4. So your finally answer is y is equal to minus 4x plus 8. This is the answer. We got the same answer in the previous place. Minus 4x plus 8. This is the second approach. The first approach was using the direct formula. Second approach is using the functional form of a straight line. Y equal to mx plus c, or the intercept form of a straight line. But you don't have to do this much work at all. Why? Why? Because when you look at the points, there is a peculiarity. There is something remarkable about these 2 points. Can you tell me what is so remarkable about the 2 points given? Please let me know. Anybody? Anjali, Robin, Trisha, Olivia. Can somebody tell me what is so remarkable about the points? Points, the 2 points has something very peculiar about them. The 2 points given in the question are not just random points on the line. They have some peculiar property. Yeah, very good. They are the intercepts because 0, 8 is the point on the y-axis. 2, 0 is the point on the x-axis. So 2 and 8 are the intercepts. 2 and 8 are the intercepts. 2 and 8 are the x and y intercepts. Clear? And if you know the intercepts, I've already told you the equation is x over x-intercept plus y over y-intercept is equal to 1 is the equation of the straight line. Always remember this. Always remember this. I've already given this in the sheet. Yeah. If x and y-intercepts are given, x over x-intercept plus y over y-intercept is equal to 1 is the equation of the straight line. We don't have to do any work at all on this question. Okay? Is that all right? Yep. Question number 3. What is the equation of the line that is parallel to the line y is equal to 5x plus 3 and passes through the point 0, minus 1? Okay. So what is the idea of parallel lines? A parallel line will have the same slope. 2 parallel lines will have the same slope. 2 parallel lines will have the same slope. Okay. The slope will be the same. So y is equal to 5x plus 3. The slope is 5. Okay. So your required line will be of the form y is equal to 5x plus c. The required line will be of the form y is equal to 5x plus c. required line will be of the form y is equal to 5x plus c. Right? Because 5 represents the slope in this case as well. Here we have to find the value c. For that, they've given a point on the line. The line passes through 0, -1. And again, you can find the value by substituting in the equation. So we have 0 is equal to -5. Sorry. -1 is equal to 0 plus c. So your c value is -1. So y is equal to 5x minus 1 is the answer. Or even otherwise, just by staring at the point, 0, -1 is the point on y-axis. So -1 represents the y-intercept, right? It represents the y-intercept. So we have y-intercept from the point, we have slope from the original line. So your answer is y is equal to 5x minus 1 without doing any work. The answer is very clear, right? Is that okay? You got the slope from the line. You got the intercept from the point. Intercept from the point. Tell me, is that okay? Yeah, next question. If a linear function passes to the points 1, s, 3, t, and 5, 10, what is the value of 2t minus s? Okay, so the idea is you have 3 points. All the 3 points pass through the same linear function, which means these 3 points are collinear. Another term, another type of question we'll talk about. The same type of question can be rephrased as what? Collinear. These 3 points are collinear. Collinear means what? They lie on the same line. Collinear. So if this is point A, the point B, and point C, how do you do the math? The slope between A and B will be same as the slope between B and C. Right? So we have A is equal to 1, s, B is equal to 3, t, and C is equal to 5, t. Using these 2 points, slope will be t minus s over 3 minus 1. Using these 2 points, the slope will be 10 minus t over 5 minus 3. These two are equated. So t minus s over 2 is same as 10 minus t over 2. 2 and 2 will get cancelled. We have t minus s is equal to 10 minus t. So we have 2t minus s is equal to 10. 2t minus s is equal to 10. Now that's all we have. But interestingly, the question doesn't talk about the values of t and s separately. What we need to ask, what we need to find out is exactly 2t minus s. Because from this just one condition, you cannot figure out the value of t and s separately. You cannot figure out the value of t and s separately. Okay, we will need more conditions. So in this case, our answer is yeah, 2t minus s is equal to 10. Our answer is 2t minus s is equal to 10. Our answer is 2t minus s is equal to 10. All right. 2t minus s is equal to 10. Let's go to the next question. What is the y-intercept of the linear equation 7y minus x is equal to minus 14? To find the y-intercept, just put, you have to find the point on y-axis. So on y-axis, x is 0. Put x is equal to 0. Your y value comes out to be minus 2, right? Minus 2 is the answer. Next question. What is the y-intercept of the line that passes to the point 1, 1 and 5, 13? What is the y-intercept of the line that passes to the point 1, 1 and 5, 13? So what we have here is 2 points. We don't have the equation of the straight line. We just have 2 points. We don't have the equation of the straight line. We just have 2 points. 1, 1 and 5, 13. Okay, from this you have to find the y-intercept of the line. Okay, no problem. Let's write the equation as y is equal to mx plus c. Okay. Right, and y is equal to mx plus c. From that, so from these 2 points, you can find the value of m. M is going to be 13 minus 1 over 5 minus 1, which is 3. So your equation becomes 3x plus c. Now substitute 1 comma 1. Substitute 1 comma 1. We have 1 is equal to 3 plus c. Your c value becomes minus 2. C value becomes minus 2. Okay. C value becomes minus 2. Clear? Is that clear? Yeah. Next question. Which of the following 2 lines are perpendicular to each other? Okay, that you need to know. If 2 lines are perpendicular, the product of their slopes will be minus 1. We have not discussed the proof of this. For the time being, we don't need the proof. I hope you would have seen this in school. Have you seen this in school? When 2 lines are perpendicular, the product of their slopes will be minus 1. Have you seen this in school? Anyway, when 2 lines are perpendicular, the product of their slopes will be minus 1. Please note it. Okay, to derive it, you will need advanced ideas from trigonometry. So we are not jumping into that right now. So if the slope of one line is known, we can easily find the slope of the line which is perpendicular to the given line. For example, if you know the slope of a line is 2, what will be the slope of a line that is perpendicular to this line? Slope of a line is 2. What will be the slope of a line which is perpendicular to this line? Can you tell me? Slope of a line is 2. What is the slope of a line that is perpendicular to this line? Can you tell me? Slope of a line is 2. What will be the slope of a line that is perpendicular to the line? One line has slope. No, I'm not talking about this particular question. I'm asking something else. Don't worry about this question. I'm just asking a different question. Slope of a line is 2. What will be the slope of a line? Yeah, -1/2, right? -1/2. Slope of a line is 1. What will be the slope of the line perpendicular to that? It has to be -1. Okay. So look for that kind of pairs. 2 -1/2. 1 -1. If it's 3, it's -1/3. And so on. Okay. Now look for those kind of pairs. In the first option, the two lines have slopes 2.5. One slope is 2, other is half. Is that the right answer? No. In the second case, we have 1 and 1. That's not the right answer. In the third one, we have 1 and -1. 1 and -1. Third one. Yeah, that is the right answer. In the fourth option, we have 2 and -2. That's not the right answer. So C is the right answer. Because, the slopes are 2 half. Here it is 1 comma 1. Here it is 1 comma -1. Here it is 2 comma -2. The lines will be perpendicular if the product of the slopes is -1. Got it? Yeah. Question number 8. The line with the equation y is equal to 3x minus 9 crosses the x-axis at the points whose coordinate is a comma b. Crosses the x-axis. So when a line crosses the x-axis, its y-coordinate will be 0. Y-coordinate will be 0. Y-coordinate will be 0. Okay, so put y is equal to 0. We have 0 is equal to 3x minus 9. So we have x is equal to 3. Okay, so 3 comma 0 is that point where it crosses the x-axis. All right. Yeah, x is equal to 3. So a value is 3. Cool. Okay. The equation of a line that passes through 7 comma 6 and is parallel to x-axis is a line is parallel to x-axis. What will be the slope of a line which is parallel to x-axis? What do you think will be the slope of a line which is parallel to x-axis? We have already discussed this. The slope of a horizontal line. No, I'm talking about a line which is parallel to x-axis. A horizontal line. What do you think will be the slope? What will be the exact value of the slope of a line which is horizontal? What is the slope of a horizontal line? Yeah, 0. Slope of a horizontal line is 0. Everyone. Slope of a horizontal line is 0. Okay. The slope is 0. Okay. So the equation is y is equal to mx plus c. So y is equal to 0 times x plus c. So it is of the form y is equal to c. Always remember the equation of a horizontal line will be of the form y is equal to c. Equation of a horizontal line is of the form y is equal to c. Okay. What is the equation of the x-axis then? Y equal to 0. Equation of x-axis is y is equal to 0. Equation of the horizontal line is y is equal to some constants. Equation of a horizontal line is y is equal to some constants. Equation of a horizontal line is y is equal to some constants. Okay. Equation of a horizontal line. y is equal to constant. Now you substitute the point 7 comma 6. There is no x to be substituted here, but if you substitute 7 comma 6, we have only y here, so 6 is equal to c. The c value 6. The c value 6. So y is equal to 6 is the answer. Y is equal to 6 is the answer. Right? Y is equal to 6 is the answer. 6. This is 6. Okay. 6. So equation of the horizontal line is y is equal to a constant. Don't forget. Equation of a horizontal line is y is equal to a constant. Equation of a horizontal line is y is equal to a constant. Yes. Next question. A line passes through the points minus 1, comma 2 and 5, comma b and is parallel to the graph of the equation 4x minus 2y is equal to 13. What is the value of b? That's a very interesting question. Because, a line passes through these 2 points and is parallel to this line. Okay. So, there is an unknown line. There is a given line. What is the slope of the given line? What is the slope of the given line? 4x minus 2y is equal to 13. What is the slope? What is the slope of this line? This line. What is the slope of this line? What is the slope of the... Hey, do not forget this, okay? See, when a straight line is given in the y is equal to mx plus c form, okay, the slope is directly m. When it's in this form, ax plus by equal to c, or ax plus by plus c is equal to 0, the slope is minus a over b. Minus a over b. Okay, minus a over b. Do not forget, it's minus coefficient of x over coefficient of y. Minus coefficient of x over coefficient of y. Minus coefficient of x over coefficient of y. Do not forget it, okay? Else you have to rewrite this into y equal to mx plus c form. Okay, if you rewrite this into y equal to mx plus c form, we have 4x minus 2y is equal to 13. We have 2y is equal to 4x minus 13. So y is equal to 2x minus 13 by 2. So if you rewrite in this way, 2 is the slope. Otherwise, to directly get the slope, this is minus of 4 over minus 2, which is 2. 2 is the slope. Got it? So 2 is the slope of the given line. There is a line given in the question. 2 is the slope of that line. Okay, got it? Yeah. And the required line passes through these 2 points. So from that, you can find the slope of the required line. The slope of the required line, slope of the given line should be the same because they are parallel. They are parallel. Okay, so from that, we have b minus 2 over 5 minus minus 1. 5 plus 1. That is equal to 2. B minus 2 by 5 plus 1 is equal to 2. B minus 2 by 5 plus 1 is equal to 2. B minus 2 by 5 plus 1 is equal to 2. B minus 2 by 5 plus 1 is equal to 2. B minus 2 by 5 plus 1 is equal to 2. Got it? Yeah. So b minus 2 is equal to 12. B is equal to 14. B equal to 14 is the answer. B equal to 14 is the answer. This is a very nice question because there are three concepts involved. One is from the equation of a straight line, how will you get the slope? Two, when there are two given points, how will you calculate the slope? Three, if there are two parallel lines, you have to equate the slopes. Got it? Yeah. So with that, we are moving on to system of linear equations. System of linear equations. A system of linear equations in two variables. Okay, we already seen that a linear function can also be interpreted as a linear equation in two variables. So if I have a system of linear equation, it simply means that we have more than one. We have more than one linear equations. Okay, and it also means that by default they are connected by and. So if somebody tells you 2x plus 3y is equal to 5 and x minus 2y is equal to minus 1. Somebody tells you this. This simply means that they are connected by and. Even though nobody has written and there, it means that they are connected by and. Which means any x comma y that will satisfy the solution, the system of equation will satisfy both conditions. Okay, any solution of the system, okay, any solution of the system will mean that that solution has to satisfy both the equations simultaneously. Okay, both the equations simultaneously. So there are multiple ways to solve these kind of equations. So I hope you would have already come across substitution, elimination, the graphical approach. Okay, I hope you would have come across all this. Substitution, elimination, graphical approach. Okay, we'll quickly discuss it and then we'll move on to problems. Okay. So when you have a system of linear equation, when there is something called solution to the system, okay, solution. We are concerned about the solution. Okay. A solution means an ordered pair x comma y that will satisfy both the equations. Solution means an ordered pair x comma y that will satisfy both the equations. A solution means an ordered pair x comma y that will satisfy both the equations, right? Both the equations. So what do you think will be the geometrical interpretation? What do you think will be the geometrical interpretation of the solution? What do you think will be the geometrical meaning of the solution of a linear equation? What do you think will be the geometrical meaning of a system of linear equations? If you have two linear equations, if you go and plot, what shape are you expecting? If you plot these two equations on a graph, what are we expecting? What shape are we expecting? It will be a pair of lines, right? I'm sorry. It will be a pair of lines, right? It will be a pair of lines. And what will solution signify? A solution will signify the common points on these two lines. Or if there are multiple points, the common points. Yeah, the point the point where it intersects, the line intersects. It's not intercept, it's intersect. Okay. The point where these two lines intersect, the common point. Yeah, right. The common point. Okay. Because the common point will satisfy both the equation. For example, say in this particular case, if you just take one equation, 2x plus 3y is equal to 5, this has infinitely many solutions. Why? Because every point on the straight line corresponds to a solution to the equation. If you take just one equation, it has infinitely many solutions. Why infinitely many solutions? Why infinitely many solutions? If you take any point on the line, it is going to satisfy that equation. Right? Now comes the second line. We have x minus 2y is equal to minus 1. Okay. And even for the second line, any point on the second line will be a solution to the second equation. Okay. Now, when you take the system, we are talking about the common solution, the intersection, right? This is our red line, and this is our blue line. Okay. The solution corresponds to the point where they intersect. Clear? So, one other way to understand the solution to a linear equation is using the graphical approach. You draw the graph. Okay, you do the graph. You draw the graph and you get the solution, right? Draw the graph, you have the solution. You draw the graph, you have the solution. Of course, if you have a graphing calculator, I don't know whether you have a graphing calculator. If you have a graphing calculator, you don't have to draw the graph using pen and paper. You can plot it, right? Do you have a graphing calculator? Casio or TI. Okay, please check whether you're allowed to take a graphing calculator for the SAT. Okay, if you're allowed to use a graphing calculator, yeah, then you can utilize it for plotting a graph. Just plug in the number, plug in the equation, you'll get a graph. Okay, cool. But graphing may not work always because sometimes if you do not have access to calculator, or if you do not have access to a graph paper, you can't get the accurate values, right? See, in this case, the answer is 1,1 because you have a very accurate graph paper. Just by looking at the graph sheet, you know the answer. But what if you did not have a graph paper in the background? It is difficult, right? I'm sorry, what happened? I'm sorry. The GeoGebra app crashed. I mean, the entire iPad crashed. X minus 2y. Two x plus 3y is equal to 5. X minus 2y is equal. By the way, you can use this software. Okay, you get used to this. I think you're using Desmos instead of GeoGebra. You use Desmos in school. Do you use that software? Yeah. Okay. So get used to that. Okay. So if you don't have a graph paper, it's very difficult. So this is not really a good approach to get the solution, the exact value, especially if the solution is not an integer, the solution of the ordered pairs are not integers. If they are integers, okay, you can approximately get the values. But if they say, suppose the answer is 3.127 and 4.756, it's not easy to find out from the graph, right? By drawing the graph, it's difficult to figure out that the answer is 3.157, 4.257. Okay, but if they are integers, yeah, not a problem. Yeah. So when coming to graph, I have to discuss some more points. Okay. So one method is just draw the graph and the point of intersection is going to be the solution, but there is a catch. There is a catch. There could be cases where the graph is not intersecting. The graphs are not intersecting. What does it mean? What does that mean? If the graphs are not intersecting, what does that mean? They could be, the lines could be, what is the other? They're parallel. Yeah, very good. The lines could be parallel, or they could be coincident, which means one line can lie exactly above the other line. Means both equations could represent the exact same line. Okay. So in this case, in this particular case, we saw that there were two lines and they were intersecting at one single point. But there is a possibility of the lines being parallel. And there is a possibility of the lines being coincident. Coincident means what? A line will lie completely above the other line. So the two equations are going to represent the same line on the graph paper. They will be indistinguishable. Got it? Yeah. Now let's see how we can figure out parallel lines from and coincident lines from the equation of a straight line equations. Okay. So listen carefully. Please listen carefully. Please listen carefully. So if I have an equation, see, in general, an equation can be given in multiple ways. For example, x minus 2y is equal to minus 1 is one way to give an equation. X minus 2y plus 1 is equal to 0 is another way to write an equation. Y is equal to x by 2 plus 1 by 2 is another way to write the same equation. Right? So there are multiple ways to write an equation, but I recommend you to use this notation. Why? Because there is no confusion here. The idea is you have to keep 0 on one side, everything else on the other side. Keep 0 on one side, everything else on the other side. 0 on one side, everything else on the other side. Okay. Make 0 on one side, everything else on the other side. All right. So let us use this approach. Now tell me one thing. If I have a line, say for example, 2x plus 3y minus 5 is equal to 0. This is one of our lines. 2x plus 3y minus 5 is equal to 0. Is one of our lines. Now suppose if I multiply the entire expression with some constant. For example, say I'm going to multiply the entire equation with 2. 4x plus 6y minus 10 is equal to 0. What happens? What happens? What happens? It represents the same line, right? It represents the same line on the graph paper. It represents the same line on the graph paper. Am I right? You have 2x plus 3y minus 5 is equal to 0. No, hold on. They are not parallel. They will represent the same line. They will be coincident. Why? Because these two conditions are exactly the same. Don't you think so? These two conditions are exactly the same. right? So if I go and plot both the conditions, I will plot 2x plus 3y minus 5 is equal to 0. That's one line. I'll give red color to this graph, and I will plot 4x plus 6y minus 10 is equal to 0. And I will give blue color here. Now this is the blue graph, this is the red graph. Blue, this is the red. This is the blue one, this is the red one. And they are coincidence. They are coincident. You know why it happens so? Please don't get confused with the parallel lines, because we are talking about, first of all, we are talking about coincident lines. They will represent the exact same equation, but the coefficients can look different the first glance. The coefficients look different the first glance, but they represent the exact same equation. I hope this is clear. I hope this is clear. Okay, please don't get confused. This is not parallel. Okay, this is not parallel. So when you have two lines, how do you check whether they are coincident? The coefficients will be proportional. The coefficients will be proportional. See, what is proportional means? They will be in the same ratio. The coefficients 2 over 4. The x coefficients are in the ratio of 2 is to 4. Y coefficients 3 is to 6. The constants minus 5, minus 10. Don't you see that they are exactly the same? They are all same. They are all same. See, this simply suggests that the second line is obtained by multiplying the entire equation with another constant. That's all. No big deal. Don't you see that? Don't you see that? Yeah. So suppose if we have two lines, a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, they will represent coincident lines. When a1 by a2 is same as b1 by b2 is equal to c1 by c2. Please understand this concept. Okay, there's nothing to mug up here. There's nothing to memorize. You have to understand that these lines will be coincident lines if and only if the two equations are exactly the same, which means the coefficients should be proportional. Coefficient could be same as well. Okay, in a special case, they could be exactly the same. Okay, but it will still represent the same line if the coefficients are proportional. Coefficients are proportional, right? I hope this is clear. I hope this is clear. Yeah. Okay. Now, in this case, we say that the system of linear equation has infinitely many solutions. In this case, we say that system of linear equations has infinitely many solutions. Infinitely many solutions. Why? Because, see, one line is lying completely on the other line. So any point on the first line is also a point on the second line. So when you talk about the common points, every point is a common point. Every point on these two lines is a common point, right? So it has infinitely many solutions. Okay. We say that the system is consistent. Consistent means it has some solution. We say the system is consistent with infinitely many solutions. Please note it down. I'm sure you would have seen this in school, but I am Just plan to give you a better insight. What is really happening here? Cool. Yeah, that is clear, right? Coincident lines is clear for everyone. Coincident lines means they represent the exact same lines, which means the coefficients will be proportional. And it also means that the system has infinitely many solutions. We say that the system is consistent. Consistent means the system has some solution. It is consistent means it has some solution. Yeah. Consistency means it has solution. It can be unique solution. It can be infinitely many solution. It can be two solution, three solution, whatever. Anyway, we will see that uh, in a system of linear equation, two variable, there will be only three cases: infinitely many solutions, no solutions, and a unique solution. Anyway, now see in these two equations, we have one of the lines as 2x plus 3y minus 5 is equal to 0. The second line is 4x plus 6y minus 10 is equal to 0. Since the coefficients are proportional, they are going to represent the exact same line. But now, what I'm going to do is, if I slightly change this number, if I slightly change the constant in one of them, okay, if I change the constant in one of them, what happens? This proportionality remains intact and this is gone. Okay, I'm going to break the second proportionality, but I'm going to make the first proportionality intact. I'm not doing anything to that. I am just changing the number 10 to some other number, say for example 9. What really happens? Let's see. See, they are not coincident anymore. They are not coincident anymore. They are now parallel. They are now parallel. They are now parallel. Remember, we changed only the c, the constant here. We did not change the coefficients of x and y. We did not change the coefficients of x and y. We only changed the constant c. Understand what is happening here? Yes. Why did that happen? Why did the lines become parallel? Why did the line become parallel? Why did the line becomes parallel? That's very easy to understand because you're not doing anything to the coefficients. We already know that if you know the equation of a straight line, you can figure out the slope. What is the slope of the first line? So in the second case, we are going to consider these lines. 2x plus 3y minus 5 is equal to 0. We have 4x plus 6y minus 10 is equal to 0. Right? No, it's not minus 10. I'm going to take minus 9. Now tell me from the first equation, uh, in this case, let's take. In the first equation, what is the slope? What is the slope? Slope is given by, we are talking about the previous case, okay? What is the slope? Slope is given by minus coefficient of x divided by coefficient of y. Minus coefficient of x divided by coefficient of y. So minus 2 over 3. What is the slope here? It is going to be minus 4 over 6, which is same. Same. In case of coincident lines, the slopes are same. Why? Because they are exactly the same line. They are exactly the same line. Okay. Which means their slopes will be the same. Their y-intercept, x-intercepts will be the same. Right? X-intercept of these two lines will be the same. The y-intercepts will be the same. The slopes will be the same because the lines themselves are the same, exactly the same. right? Yeah. When it comes to two of these two equations, what I've done is I've taken the same first equation. In the second equation, I've just changed the constants. I've not touched the coefficients of x and y. They remain intact. Now what happens? What is the slope of the first line? Please tell me what is the slope of the first line. What is the slope of the first line? What is the slope of the first line? What is the slope of the first line? Please tell me. Slope of the first line. Anybody there? What is the slope of the first line? The slope of the first line, I've already told you. If I have a linear equation, the slope is given by minus coefficient of x by coefficient of y. If the equation is written in this form, ax plus by plus c is equal to 0, minus 2 over 3. Here the slope is minus 4 over minus 4 over 6, minus 2 over 3. Yeah. The slopes are the same. The slopes are the same. But since this proportionality is broken, they are not the same lines anymore. Since this proportionality is broken, see, this is 2 over 4 here. This is 3 over 6 here. It's minus 5 over minus 9. These two are equal, but this is not equal. Since the proportionality is broken, they're not the same line anymore. But since the slopes are the same, slope gives an indication of the direction of the line, right? Since the slopes are the same, the lines are the same direction, which means they are parallel. The lines are parallel. Okay, they are not coincident, but they are parallel. See this? Now, if I change it to some other number instead of minus 9, if I make it as minus 1, this will be parallel. Clear, 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 clear. Why the lines are parallel? Why the lines are parallel? The slopes are the same, but they do not represent the same line. The slopes are the same. So since slopes are same, the directions are the same, which means they are parallel. Slopes is an indication of the angle the line makes with the x-axis, positive direction of x-axis. Yeah, that is also true. That is also true. The y-intercepts are different. X-intercepts are different. They are different lines. They are different lines. But they are parallel. Okay. So for parallel lines, we need to have this. What is the condition we need to have for parallel lines? We have A1 over A2 is equal to B1 over B2, not equal to C1 over C2. Clear? Compared to this, the difference is this. Compared to this, the difference is this, right? Am I right? Yes. And in this case, we say the system is inconsistent. Inconsistent. Which means there is no solution. Why no solution? There is no common point. There is no common point. There is no common point. Inconsistent means no solution. Consistent means it has some solution. Inconsistent means it has no solution. Is that clear? Clear, clear, clear. The concept is clear, right? The idea is very clear. Of course, there is one more case where the lines will intersect. Okay, there is one more case where the lines will intersect. In that case, the idea is very simple. The slopes will not be the same. Slope will not be the same. So, which means the lines will have different directions, which means they are bound to intersect. Okay. If the slopes are same, there could be two possibilities. The lines could be parallel or they could represent the exact same line. So, these are the two cases where the slopes are same. In one case, the lines were exactly the same. In the second case, the lines were not exactly the same, but the slopes were same, so they were parallel. Cool. And of course, there's one more case. We'll discuss that in the next class. Okay, I'll share a sheet with you. Please do not forget this stuff for the next class because we'll continue on this. Continue from here. Okay. See you.